Hi, I'm Giovanni, MS course students in Compiler Lab. The paper that I representation is Dynamic Channel Allocation for Multi-UAVs, a deep reinforcement running approach. First, I'll explain about multiple UAV system property. As the increasing number of communication device, limited spectrum resource make the number of channel limited. And UAV usually has high mobility, so the channel allocation algorithm is required to gain in short time. With this property, it's necessary to ensure each UAV can communicate successfully without interference with other UAVs. So channel allocation is important task in multi-UAV system. For channel allocation, fixed channel allocation strategy is traditionally used. Fixed number of channel allocation to device, and device only use the allocated channel. That's the method of fixed channel allocation. It's not use complex algorithm, but when multiple devices are communicated at the same time, the spectrum resources are wasted. To solve this problem, dynamic channel allocation strategy is used and it maximizes the use of spectrum resource. The basic idea of reinforcement learning is to maximize the cumulative reward value of agent from environment, and we can adapt the channel allocation system in multi-UAV system effectively. The traditional method of reinforcement learning like Q-learning can be used, but real-world tasks become more complex, and it's challenging to generate and retrieve the data from Q table when the data gets bigger and bigger. In this paper, they use deep Q network algorithm integrated with LSTM. By using LSTM, the historical information can help the UAV to learn characteristics of environment more quickly. Next, I will explain system model. They assume that each UAV operates in slotted time manner, as shown figure 2. In each time slot, the channel state is scanned first in period T. If there are free channels after scanning, UAV will transmit information in next TC. And after transmit receive state feedback in third period of TL till end of time slot. Next, I'll explain the QN formulation. The Q value of state can be obtained by reward plus discount rate gamma multiply maximum is estimated value Q. The neural net parameter are updated as old parameter plus learning rate multiply difference between Q value and updated Q value. When we adapt it in drone scenario, since the drone operate is highly dynamic, they use distance from the drone to receive terminal as reward function. When two or more drones access the same channel, collision occurs and reward value get negative constants. When UAV does not access any channel, reward value becomes 0. In other general case, reward value defined 1 minus log d, and d represents distance between drone and receiver. Update of Q value is similar to DQN by adding learning rate multiply difference between recalculated Q, it mean and old Q value, and recalculated Q value means reward plus gamma multiply max of Q. When Q value is updated, we choose the following action. In 90%, we use the general max of Q value, and in 10%, we choose random action. Next figure 4 represented the proposed DQN plus LSTM structure. By using LSTM history information, we can help UAV to learn the characteristic of environment more quickly and speed up the convergence algorithm. Mm, Next shows algorithm structure. For every time slot, each UAV select action and get feedback from environment and state and action information goes into LSTM, and LSTM output goes to DQN, and DQN computes estimated Q value and update Q value. After that, we can obtain the channel allocation strategy. Performance evaluation has three methods. First one is average collision rate, and second is average reward, and third is average successful communication rate. You need to careful that ASCR does not mean 1 minus ACR, because it contains they means non-access is same as failure, so they are different. As you saw, figure 6 shows the ACR, the proposed method of ACR converged more faster than other method, and figure 7 shows proposed method reach the highest reward value, and figure 8 shows a proposed method is 5% higher than other two algorithm in ASCR. Thank you for watching.